Hey math students, it's Mrs. Marcellus in Gottlieb. In today's lesson we're going to take a look at three very important properties of addition and multiplication that will help us solve algebraic problems. Today's learning objective: students will simplify algebraic expressions by applying the commutative, associative, and identity properties of addition and multiplication. Since today's lesson is learning about the properties and how they are used, I won't be providing any definitions here. We'll just take them one at a time. How does that sound, Gottlieb? The first property we'll take a look at is the commutative property. The commutative property says the order does not change the value. This applies to addition and multiplication problems. You can think of commuting back and forth from home to work or school. Let's say you're going to drive from home to work and the distance is 10 miles. If at the end of the day you drive back home taking the exact same route, it's still 10 miles. The order does not change the distance. We can represent this using symbols. For example, if we have Pythagoras and Fibonacci, it's the same thing as Fibonacci plus Pythagoras. In addition, 7 plus 3 equals 3 plus 7. You can see that switching the order does not change the end result. Both expressions are equal to 10. This can also be used with variables. If we have an unknown number plus 10, that would equal 10 plus that same unknown number, represented here by the variable a. The commutative property also applies to multiplication. When we're working with numeric expressions, such as 5 times 9 and 9 times 5, we can switch the order and still get the same value. This also applies to algebraic expressions. Next, let's look at the associative property. With the associative property, the grouping does not change the value. This also applies to addition and multiplication. You can think of a group of 3 people who change who they associate with. Let's say that Einstein and Fibonacci are working together on a problem, and Pythagoras is working all by himself. Then Einstein is working by himself, and Fibonacci and Pythagoras are working together. The grouping of who was working together changed, but we still had all 3 together in the same room. When working with addition, we can see that it doesn't matter how we group the numbers, we'll still get the same results if we have all addition. 8 plus 6 is 14, plus 9 equals 23. We can also see that 8 plus 6 plus 9 would be 8 plus 15, which also equals 23. The content of the parentheses changed, but the order of the numbers did not. This will also work with algebraic expressions. Once we know what a is and can plug it in, we would get the same value either way you approach the problem. This also applies to multiplication. When we have all multiplication, it doesn't matter how we group the numbers to multiply them. This will also apply to algebraic expressions. Next, let's look at the identity property. The identity property says that adding 0 or multiplying by 1 does not change the value of a number. This applies to addition and multiplication. If we have Gottlieb and we add 0, we simply have Gottlieb. If we add 0 to any number, we have the original number we started with. We can also apply this to algebraic expressions. If you add 0 to any variable, you will still have the variable that you started with. If we would multiply Gottlieb times 1, we would still have Gottlieb. Any number multiplied by 1 will equal the number you started with. This is also true for any variable. Now that we have defined these 3 properties, let's apply them to some examples. In these problems, we are going to determine whether the two expressions are equivalent. If so, we will identify the property, and if not, we'll need to show or explain why. If we have 6 plus 7, that equals 13. 13 plus 12 is 25. In the next expression, we have to do the parentheses first. 7 plus 12 is 19. 6 plus 19 also equals 25. Therefore, these two expressions are equivalent. Since it is the grouping that changes, the content of the parentheses changed from 6 plus 7 to 7 plus 12, this is an example of the associative property. In this problem, we have 55 and 1 times 55. 1 times 55 does equal 55, and this is an example of the identity property. Let's examine this problem. 72 divided by 9 equals 8. 9 divided by 72 is 9 over 72, which simplifies to 1/8. The commutative property does not apply to division. For your answer, you would write no, because they are not equivalent, and then for an explanation, you can simply state that 8 is not equal to 1/8. In this problem, if we multiply 11 times 26, we get a result of 286. If we multiply 26 times 11, we also get a result of 286. In this problem, it is the order of the numbers that is changed. Therefore, this is an example of the commutative property. Let's check out this problem. It looks like an example of the associative property. We must do what is inside the parentheses first, so we'll have 30 minus 3, which equals 27. On the other side, we'll subtract 10 minus 3 and get a result of 7. 40 minus 7 equals 33. We can see that they are not equal to each other. The associative property does not apply to subtraction. Our answer is no, and that is because 27 is not equal to 33. Let's take a look at this problem. 2 times 9 is 18, and 18 times 14 is 252. On the other side, our parentheses contain 2 times 9, which is 18, and 14 times 18 is 252. We have to look very carefully to determine whether it is commutative or associative. If we look at the parentheses, the contents of the parentheses themselves has not changed. So this is not an example of the associative property like we might first think. The thing that is changed is the order of the numbers. This is actually an example of the commutative property. The entire parentheses times 14 has been swapped. On this side, the 14 is first, times the entire content of the parentheses. You have to look very carefully. What might seem to be the associative property could possibly be commutative. In our next couple of problems, we're going to use one or more properties to rewrite the expression without parentheses. Since we don't know the value of y, we cannot evaluate the expression. However, we can rewrite the problem using the associative property and changing the grouping. If we do that, we would have y on the outside plus 12 plus 15 on the inside of the parentheses. Then we can solve this part of the expression, leaving us with y plus 27. Here we have multiplication. In order to rewrite this expression without parentheses, we're going to have to take a couple of steps. The first thing we can do is apply the commutative property. We can switch the order of 6 times s and make that s times 6, with the times 8 on the outside. Then we can use the associative property to regroup using our parentheses. That would leave us with S times 6 times 8 inside the parentheses. We can then multiply 6 times 8, and that will give us S times 48. And finally, we'll use the commutative property again to switch it around to our final answer of 48 times S. Let's apply our properties in a couple of word problems. 4 goats each weigh 84 pounds. Write 2 equivalent expressions using the commutative property that can be used to find the total weight of the goats. In order to find the total weight of the goats, we will need to multiply the number of goats times the weight. One way we could write this is 4 times 84. A second way we could write it is 84 times 4. They are equivalent, and this is an application of the commutative property. Either one of these is going to show us that the goats weigh 336 pounds altogether. At a petting zoo, there were 2 Angora goats, 5 kinder goats, and 3 pygmy goats. Write 2 equivalent expressions using the associative property that can be used to find the total number of goats. We know that the associative property changes the grouping of the numbers. In order to find the total number of goats, we will have to add them together. We could first add 2 plus 5 and then add 3, or we could write the problem a second way. 2 plus 5 plus 3 with the 5 plus 3 in parentheses. The order of the number hasn't changed, but the content of the parentheses, the grouping, has. So this is an application of the associative property. Either way we solve this, we will get a total of 10 goats at the petting zoo. Really, Gottlieb? Wow, that's pretty interesting. Gottlieb was just telling me that there are more than 210 breeds of goats in the world. That's kind of like people. There are a lot of different nationalities of people. Well, math students, this concludes our lesson on the commutative, associative, and identity properties. Look for the distributive property coming soon. Bye for now.